Okay, this is part 5 in this series devoted to Improv Card Magic. Now today we will begin with 14 card packets. Okay, so I have a shuffled deck of cards here. And as you can see, we're going to look at something I haven't shown you yet. It's a kind of cool system for keeping track of the number of red and black pairs in such a way that you don't mentally become overwhelmed with the job. Okay? In fact, why don't we just take a minute and kind of explain this. So let's say we have these 14 cards here, and these are the colors of the cards starting from the top of the deck. So red, red, black, 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 and so forth. Okay, so here is a very interesting, simple system for keeping track of the number of red and black pairs if a person wants to go that route. So what you do is you associate with 2 red the number 10, okay? And then associate with 2 blacks the number 1. And then opposite colored pairs count as 0, so essentially just leave those, ignore those. Okay, that's probably the easiest thing mentally. So just skip those. So I see a red pair, so I think 10, and then I see a black pair, and I add 1 to it. So now in my mind I'm just thinking 11. Okay, so that's the number I'm thinking. Okay, nothing. Oh, I got another 10. Well, 10 plus 11 is 21. Come over 1. Oh, I got another 10 plus 21 is 31. And then over here, oh, I got a pair of black cards. So we add 1 to that, 31. So we get 32. So in my mind, I just need to remember the number 32. And remember that the tens place, the digit in the tens place, tells me how many red matching color pairs I have, and the ones place tell me how many black color matching pairs I have. So if I can just hold on to the number 32 throughout the performance, I can reconstruct the number of pairs that will either be red or black. Okay, so I thought this is a fun system to share with you, especially as the packet sizes here are getting a bit bigger. Okay, so as always, we need 3 random piles here of 14 cards each. So let's go ahead and do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we have 3 piles of 14 random cards each. So what we'll do is we'll go ahead and just put these out of the way for a moment. And then if you remember, what we do is we pick up any of the 3 piles, actually. And then at the start here, just for the sake of the performance, my presentation here, we're free to look for an AMP mirrored or 2-cycle structure for the first pile that we pick. So maybe we'll choose this one to work with first. Okay, so just keep in mind, we're going to take a look at all 3 structure types for this one. Now, as we choose a structure for this one, it's going to limit the number of possibilities for the other 2, right? Okay, so let's just see how we're doing. Okay, so here we go. So we have 14 cards, getting kind of big. Okay, so let's go through. In fact, we could probably just use my system right here if you would like. So remember a black, so we're going to look at AMP. So a black pair, we think of that as a 1. So we have 1. Here's another black pair. 1 plus 1 is 2. Opposite pair, ignore. Oh, a red pair right here. So we add 10 to the 2. So it's 12. So another red pair would give us 22. Nothing here. And then we get another red pair, 32. We actually got the number I used as an example. That's funny. Okay, so that's viewing it as an AMP. So we get 32. So we'll go ahead and view this. Treat this as an AMP. Okay, very good. Okay, and where all we need to do is keep in mind 32. So if you need to jot that down, that's fine. Remembering a two-digit number, if that's the only thing you need to remember, is probably not too much for most people. Okay, so this first one is an AMP, and if you remember, the number associated with this little packet is 32. Remember that, 32 right there. And the tens place, namely the 3, tells us that we will have in the end 3 red pairs. And the single digit 2 tells us that we will have 2 black pairs. Okay, so that's the deciphering of our number 32. Let me bring up our shuffle table here so you can see that we're following things faithfully. Now this is an AMP, and as we've seen in previous videos, a Bessie 2-2, which is on line 16 there on the left, it will preserve an AMP structure. So this is where you take 2 from the top, 2 from the bottom, 2 from the top, 2 from the bottom. So you go 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top. That is a Bessie 2-2, and it preserves AMP structures. Now, in our table on the left, if you look at line number 11, the up jog, that will always take an AMP to a 2 cycle. So let's go ahead and do that. Now, it can be an even up jog or an odd up jog. Either one will accomplish this. And you can have the spectator decide which of those two to use. Strip this out with random stacking. Maybe the spectator wants it stacked like that. It is now a 2 cycle. Being a 2 cycle, we can now cut the cards freely, have the spectator do that. Or more powerfully, we can perform a Charlier shuffle, top to bottom, bottom to top. Okay. This is one that I have a video for, you remember? So top goes on the bottom, some from the bottom go on top, top to bottom, some from the bottom go on top, top to the bottom, then maybe this bottom one goes on top. All of that movement of the cards is equivalent to just cutting the cards at some location. Hence, it is still a 2 cycle relative to the pairings that we made note of. Now, a common way to go from a 2 cycle to a mirrored structure is to use a Klondike shuffle. And that's in our chart on the left, it's line 14. So the Klondike shuffle will convert a 2 cycle structure to a mirrored structure. Now this is where you take the top and bottom card off as one and then just drop them on the table, and do that until all of the cards have been moved from one hand to the other. It is now mirrored. Now once it's mirrored, we have the stay stack principle, which opens up a whole universe of structure preserving mixing of the packet. But we'll go ahead and just do an LR, left, right, with random stacking of the left pile on top of the right or right on top of the left. The spectator can decide this. Okay, it's still mirrored. Now just make note of the fact that we can deal out as many piles as we like as long as that number is a divisor of our packet size. So 2 divides into 14 evenly, and so does 7. So technically, and we'll probably use it over here, you could deal out into 7 piles and then stack from left to right or right to left, and it will preserve a mirrored structure. Okay, now to go from a mirrored to a 2 cycle, one of several ways will be to use the Monge shuffle. Now that's line 13 in our table on the left. So if you want to take a look at that, we can do an over-under or an under-over. Okay, so maybe the spectator will say, do a over-under. Okay, so over, under, over, under, over, under, over, under, over, under, over, under, over. Okay, we are back to a 2 cycle. Okay, now what we're going to do is we're going to deal the cards into 6 piles. Okay, just like you would for a, we're now going to deal the cards into 7 piles using, quote, LR dealing, but we won't stack them this time, okay? So why don't we'll go like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so since this was a 2-cycle, just think about it. If you think back to our 2-cycle structure, you can think of it as like 1, 2, 3, 4, 5, 6, 7, followed by 1, 2, 3, 4, 5, 6, 7. That's a 2-cycle structure. So if we did 1, 2, 3, 4, 5, 6, 7, and then we did 1, 2, 3, 4, 5, 6, 7, what that would do is it would group together the special pairings. Like all the, quote, 1s would be together, the 2s, 3s, 4s, up to the 7s. So now we have what's called a DMP. Okay, so DMP means we have distinct mirrored pairs. So we're essentially done at this point. This is what we were hoping to find. Okay, now if you remember, the special number that we remembered, we squirreled away for this, was the number 32. Okay, and the 3 tells us there's 3 red matching pairs, and the 2 tells us there's 2 black matching pairs. Okay, so what you could at this point, there's a lot of ways to proceed, but you'll probably, in this case, you'll probably want to divine that before you show it. And so you can come over here and go, well, I'm trying to get a feel for, like how many of these pairs are opposite color, how many are black cards, and how many are red. For the red pairs, I'm just in my mind's eye, I'm seeing the number 3. It's kind of weird. So I think there's 3 matching red pairs. Okay, what about black pairs? Are there any pairs here of black cards? No. Oh wait, no. I think there are some. I think there's. Oh, yeah. Okay, yeah. I can see it now. It's 2. We have 2 of these matching in color, and they're black. So we have 3 red pairs and 2 black pairs. Let's see if I divined that correctly. Was I sufficiently sensitive to perceive this without actually looking at the pairs? Okay, so let's see. What was it again? Yeah, 3 red pairs and 2 black pairs. How did we do? Oh, there's a black pair. And we said there'd be 2 of those. Oh, check it out. Oh, but we don't want any of these to be black. So there's 2 black pairs, and then we're thinking there's 3 red pairs. No, that's non-matching, so it doesn't hurt yet. Oh, we got 1 red pair. So there's got to be 2 of these have got to be red pairs for me to be correct. Let's see. Oh, I got a second one. Oh no, stress. So we want 1 of these over here to be a red pair, 1 of these to be a red pair, and the other one to be non-matching. Okay, why don't we do this one way over here? It's essentially off the... Oh, we got 1. Okay, so right now we have... Maybe I'll put it like this. Our prediction is true. As of this moment, we have 3 red pairs and 2 black pairs. So I'm just praying that these are not of the same color. Otherwise, I've blown it here. I did not correctly feel what the universe had given me. Oh, those are of opposite color. We nailed it. We got exactly 3 red pairs and exactly 2 black pairs. Look at that. Aren't we amazing? Okay, so that is the first one. First little demonstration. And hopefully you can see how well our little system worked for just quickly noting, so 3 red pairs, 2 black pairs, and just having to remember just 1 2-digit number to finish this. I mean, that's not too much information to require someone to remember.